Thanks for invitation. I'm sorry I can't be there in person. I'd like to talk about new CTO devices, Anteowl IVUS, Conquest Pro 12 ST, and orbital atherectomy. This is OAS system. They are composed with OAS pump, atherectomy device, dedicated guide wire, saline tube, and lubricant. In OAS, lesion with different vessel diameter can be treated with a single atherectomy catheter. The probing sheath is compatible with 6 French guide. We can use guide extension catheter in case. Guide wire is locked by the black button so that the wire doesn't move without off the lock. The orbital rotation of the eccentrically mounted diamond crown allows effective treatment of severely calcified lesions. The tip of the OA is low profile at 0.016, so it has excellent delivery performance. However, the tip of the dedicated wire and the tip of the OA should be at least apart from 5 mm apart. The tip of the wire can easily break, so there is a high risk of it breaking. This is a promotion video.
Diamondback 60
Let's see.
is designed for calcium. It enables simultaneous modification of both intimal and medial calcium for optimal stent delivery, expansion, and apposition in severely calcified lesions. One device treats eccentric, concentric, and nodular calcium. Through differential sanding, healthy elastic tissue flexes away from the crown, which may minimize damage to the vessel. The crown's orbital motion delivers pulsatile energy at a controllable, predictable rate, prepping calcified lesions with the Diamondback 360 coronary OAS, sands superficial calcium, and fractures deep calcium. The crown's movement allows blood and saline to flow continuously during treatment, minimizing risk of thermal injury and slow-flow no-flow events. The diamond-coated crown sands intimal calcium into particulate with an average size of approximately 2 microns, which is smaller than a capillary vessel. Calcium modification with OAS optimizes stent delivery, expansion, and wall apposition, and provides physicians a high rate of procedural results in the most challenging lesions and long-term success.
I'd like to show a case. This is LCX severely calcified region. We can see almost 360-degree calcium by OFDI image. This is the OFDI image. The most severely part of the lesion is almost surrounded by 300-degree calcium. So we start to treat the lesion with orbital atherectomy OA with a low speed 8 times pushing effect and high speed 4 times pushing and pulling effect. After that, we could confirm that cut were going in the predicted direction. We can see the cut confirmed to the predicted direction toward the calcium. But in the lesion diameter is not sufficient, so we applied rotational atherectomy with a 2 mm bar to further expand the lumen, and then the lesion was dilated with 3.25 cutting balloon. This is OFDI image after rotational atherectomy. we can see the significant lumen dilation and the right direction. After cutting balloon, we confirm this significant lesion dilation with some crack on the calcium. Like here and here. Finally, we treated the lesion with 3.5 dB and got a significant result, sufficient result without stenting. This is the final OCT image. We were able to achieve the significant dilation in the region, There are some differences between these two atherectomy devices. RA is most effective for very severe calcified lesion due to its straightforward ability and powerful sanding force. OA can cut in both pushing and pulling directions, so it is also effective against calcium on the small curvature. Because of its small profile, the chance of disrupting blood flow during treatment is less than in RA, so therefore slow or no flow is considered to be less frequent. For RA, the passage of the bar is the endpoint of the device, but for RA, this needed to be confirmed by imaging. Next, I'd like to talk about Anteowl IVUS and Conquest Pro 12 ST. Anteowl IVUS has dual monorail part. The first monorail part is short and at the tip, with the second longer monorail part at the proximal. Since the wire and the IVUS are integrated over the long distance, region trackability is extremely excellent. The distance from the tip to the IVUS probe is 8 mm, so lesions can be observed without inserting the IVUS deep into the lesion. Since IVUS is not, and also since IVUS is not fixed, it can be moved freely within the probing sheath. This is the Anteowl IVUS system. The blue button is to hold the IVUS probe, and the second button is to scan. After release the hold button, we can easily move the probe. We can measure lesion length after set the starting point. Set the starting point, we can measure the length. Inserting the wire into the second monorail part is somehow difficult for the old operators. I'd like to show a case. This is with LED CTO at the bifurcation of diagonal branch. The RCA also has severely diseased. I started the antegrade wiring with IVUS using the UV3 wire. IVUS shows that the wire that toward the LED passes through the very edge of the vessel wall, close to the outside of the vessel. The UV3 wire inserted the LED, but the UV3 wire inserted the LED is thought to be the subintima, since we can see that the vessel lumen is compressed by contralateral angiography. We determined that at least this part is not outside the vessel. Then we advanced the Anteowl IVUS into the CTO region and tried IVUS guided ADR with Conquest Pro 12 ST. This is a guide wire. We rotate the wire clockwise, and then after several attempts, we are able to get a true lumen with IVUS guided tip detection. This is a real-time procedure. We can see the guide wire here, and the second operator told to me the wire direction, and then the wire got into the true lumen. Now, after that, inserted a microcatheter in the true lumen, then step down the wire into the Sion. Finally, successful recanalization was achieved. These are final angiogram and IVUS after stenting. The lesion was sufficiently dilated. These wires are manufactured by Asahi Intech. In recent years, the tip has been pull-shaped, eliminating the variations between operators. These are penetration holes of each wire. The difference between Conquest Pro 12 and 12 ST is the length of the tip and shape of the tip, which improves deflection and increases the lateral penetration force. The lineup of wires comes in different tip shapes, expanding the options available depending on the region. These are usual blunt tip, Conquest Pro Light, and blunt tip, Miracle Neo 3, and the Gaia series, Microcone tip, and the shapened tip, Conquest Pro 12 ST. Thank you very much for attention.